Let's look at problem number 4 of our linear programming packet. The Supreme Shipping Company can load its trucks with both rectangular and cylindrical containers. The rectangular container has a volume of 100 cubic feet and weighs 200 pounds. The cylindrical container has a volume of 200 cubic feet and weighs 100 pounds. Each truck has room for at most 4,200 cubic feet of containers, and each truck can carry a maximum of 4,800 pounds. Supreme Shipping charges $60 to ship either a rectangular or cylindrical container. What combination of containers should Supreme Shipping use to maximize its income? Let X denote the number of rectangular containers carried by the truck, and let Y denote the number of cylindrical containers. And I'm going to write that down again because that's kind of been our procedure. Is that X equals the rectangular, and Y equals the cylindrical. And our second step that we've been following is we've been writing the objective quantity equation, which is typically the one that deals with profit. But in this particular problem, instead of profit, what it says is Supreme Shipping charges $60 to ship either rectangular or cylindrical. I'm going to write it right underneath the graph. I'm pretty sure that I won't have enough space when we get to it, but I bet you can fit this right underneath your graph. And again, the company is going to charge $60 to ship the rectangular or the cylindrical. And third, what we know is if we're going to make any money at all, we need to assume that we're going to ship some rectangular and we're going to ship some cylindrical. So we just need to get our other two inequalities, and remember, if you can, write them side by side so that you can put them in slope-intercept form right underneath. We have two things happening in this problem, and they are not verbs, as I sometimes say, but we've got volume in this problem. It's something to do with volume. We're going to write an inequality for that. And then the other the other inequality is going to be with weight. So when we write our inequality, we only want statements about volume. In the rectangular, a rectangular container has a volume of 100 cubic feet, 100x. So we need to look for how much volume in a cylindrical container. And the next sentence says a cylindrical container has a volume of 200 cubic feet. And how much volume are we allotted in this problem? Well, each truck has room for at most 4,200 cubic feet. Less than or equal to 4,200. And I'm going to have to leave some space and move my weight down because I just really don't have enough space there. I hope that you can again write it side by side. But if we go back and we look at this problem, a rectangular container weighs 200 pounds. And now we need to look and see how much does a cylindrical container weigh. And it says that a cylindrical container weighs 100 pounds. And how much weight then, in our next sentence, it says we can carry a maximum of 4,800 pounds. So it's going to be 4,800. And now that we have that information, what we're going to do is we're going to put these two inequalities into slope-intercept form so that we can graph them and eventually find our convex polygon region in our vertices and figure out how we can make the most money. So we're going to solve for y up here in this red equation. That means that we're going to subtract 100x from both sides. And we get 200y is less than or equal to negative 100x plus 4200. Divide everything by 200. And what we do, we have y is less than or equal to negative 1/2 x. Remember your calculator will simplify that for you. Plus 21. And from that, we can identify the fact, and I'm going to try to squeeze it in here now that I had to write it vertically instead of horizontally. But from that, what we can identify is that our y-intercept is 21, and our slope is negative 1/2. We need to do the same thing here. I'm going to scoot this down just a little bit so that slope is not there. And it seems here, I think I said that the weight of this one is 4,800 pounds. And as I look there, it's 4,800 pounds, so we need to go back and fix that. I don't know quite what happened there. But once we've got that fixed, now we need to put this into slope-intercept form. So that, again, needs to solve for y. So we're going to subtract 200x from both sides. And we end up with 100y is less than or equal to negative 200x plus 4,800. And then we're going to divide both sides by 100 to get y by itself. And we end up with y is less than or equal to negative 2x plus 48. And then we can identify what's our b. Where does this graph cross the y-axis? Well, what our b is 48. And our slope then is negative 2/1. Slope is rise over run. So now, we're going to come back up here, and we're going to graph. And just a reminder, once again, if x is greater than or equal to 0, it has to cross the x-axis. So that is a vertical line. And y is greater than or equal to 0 has to cross the y-axis. So this is a horizontal line. And I hope you're using a ruler, as I'm a hypocrite and I'm not using a ruler. But I'm going to draw our line here. And I'm going to draw the line here. And then we can graph our other two. So for our red, on my particular case, b equals 21. So be careful here. It's the increments on the graph are going by threes. 3, 6, 9, 12, 15, 18, 21. Here's 21. And then our slope is negative 1/2, so we're going to go down 1 to the right 2, 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 and down 1 to the right 2. And if you aren't using a ruler, you need to put all those points in on your graph. So here's our next line, and we have one more to draw. And that's going to be with our y-intercept is 48, which is at the very top of our graph here. And then our slope, once again, is negative 2/1. So we're going to go down to the right one, 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 down to the right one. Again, if you also are not using a ruler, you want to put all of those points on there to be able to draw your line. And there's our picture. And what you're looking for is you're looking for where is the convex polygonal region. And without showing the work on this one, and I think that I've showed it on the previous 3 examples, look for that 4-sided figure here, and where we end up is we're going to end up in this area without jumbling up. But you might ask your teacher for help if that's the part that's giving you the most trouble. But once we get that information there, once we get the feasible region, which is where I highlighted it, then we can also identify the fact that this is an ordered pair, and this is an ordered pair, and this is an ordered pair, and this is an ordered pair. It's a vertice of the feasible region. And the reason why I like to write my objective quantity equation right underneath my graph is, 1, I think that there's space on this paper, and then 2, we can just fill them in. F of 0, 0. Once again, this means that we're going to use 0 rectangular containers and 0 cylindrical containers. The zeros go in for both x and y, but ultimately what that means is that we're not going to make any money at all. And again, there my space is really tight. I'm going to scoot that over, and maybe I can. Try this one more time there. Oh dear. Easier just to erase. 0 goes in for the x, 0 goes in for the y, but we have 60 times 0 plus 60 times 0. And ultimately, what we end up with is we end up with 0. So we know that's not going to be where we get our profit. And I am going to scoot this down here so that I can fit it in. Again, our objective quantity equation is f of xy equals 60x plus 60y. We just tried to put in 0, 0 for one of our ordered pairs. Unfortunately, I could not squeeze it in. But we know that we're going to end up with 0. 60 times 0 plus 60 times 0 equals 0. Well, another one of our ordered pairs from the graph is going to be 0, 21. And in fact, I think we'll come up with all of them now since I can't see them anymore. Another ordered pair. Again, remember, you just have to have all 4 of them. They don't have to be in a particular order. But as we get up here, it looks like we have 18, 12 as one of our ordered pairs. And our last ordered pair, when we go back and look at the graph, is 24, 0. We're taking these ordered pairs and we're putting them back into this quantity here. So with our green ordered pair, 0 is going to go back in here for x, and 21 is going to go back in here for y. And we get 60 times 0 plus 60 times 21. And when we multiply that, whether we type it in our calculator, we get 1260. We're going to put 18 in for x, and we're going to put 18 in for y. And when we multiply these 2 values, type it in our calculator, what we end up with is we end up with 1800. And when we put 24 back in for x, and 0 back in here for y, we get 60 times 0. When we type that in our calculator, we end up with 1,440. And now we have all the information that we need to finish this. Because what we want to know is what's going to be our profit. And our profit is going to be coming from the 0, the 1260, the 1800, the 1440. It's the biggest number, which means that our profit is going to be $1,800 if we use 18 rectangular containers and we use 12 cylindrical